All right, so yeah, so just a little bit about the class, what's going on in the class so far. We have our schedule, as usual, and we're pretty much at the end of this class, right? We have 2 more days left, including today. So today and one more day. And today's supposed to be a review module day. If you didn't read in the email that I sent, I got COVID-19 while we were on break. And so they basically required me to quarantine, to not be on campus. And so I won't be able to be back on campus until tomorrow, actually. So today we're holding our review session online. Another instructor actually also got sick, another Math 5 instructor. And so it was very difficult to find coverage for everybody. And so, since today's a review, I have a whiteboard on my iPad. We can just do it there online. So hopefully today's, it will work out okay doing it online. But then for the exam number 3, I will be back for the in-person portion of the exam. So we can, excuse me, we can do this part in class at the regular time. So we will pick up on Wednesday with the in-class portion. There will also be an online portion of the exam on ALEKS. And that's, you should know what to expect already for the exam. Exam 3 is basically just going to be exactly like exam 2, except, on the new material, the module 3. So let's go ahead and go back really quick to, David Hamley has put out this, excuse me, still have some symptoms, lingering symptoms here. So please excuse me for that. But you can read through this announcement for exam number 3. As usual, you need to do the integrity affirmation to make sure you're not going to use any resources that you're not supposed to be using. The part that's on ALEKS is going to be available for the exact same time frame on the day of the exam on Wednesday. The format will be very similar to last time. There are some practice problems that we might go over today if you would like to. And then there's going to be an in-class portion. It's a double quiz, right? Based on worksheets 5 and 6, and you have 40 minutes as before. So nothing too new here. There's also a reference sheet that can be used for the online exam, and it has a couple of identities, a couple of trig identities, and then the unit circle. Okay, so any questions? Are there any questions about, the online portion of the exam, the in-class portion of the exam? It's going to be identical to what we had before. In the sense of the structure is going to be the same. Okay, and then there's also another announcement. If you go to the one that says resources to help prepare for your last Math 5 exam, David Hamley has listed a set of resources here. And one of them is the practice exam that was available before on ALEKS. I would strongly recommend that you try that if you want to, practice there for the online portion of the exam. But then we also have, there's this bullet point here. It says, any materials provided by your instructor, such as videos. So, I've been providing videos, putting them on YouTube. So feel free to watch that. Excuse me. I'm actually recording this right now, and this will be posted up just following this class, and I'll send out a link. I'll also send out a link to the morning discussions. The 8:30 a.m. class, the 10:30 a.m. class. I'll send them all the links so you can take a look at any of those. And then, but David Hamley also created some videos. I wanted to point that out. And, he's provided a link in this announcement. So, that's kind of nice. You can go on here if you want to know a little bit more about worksheet 6 or worksheet 5. This is tailored to the worksheets that we've given in this class. And if you want to see, a different approach, I mean, it might even be the same approach. I haven't watched the videos all myself, but, you're welcome to do that. So I thought that was kind of nice there. All right, let's see here. There's something in the chat. Yeah, so and you can send a private message in the chat or just a public message if you want. So I got one here. It says, this is unrelated and you can answer after you're done explaining, but when will the extra credit be applied? I'm going to have to find out about that. The extra credit, that's a good question. I thought there was an announcement about it, waiting for extra credit here. Yeah, so there was an announcement that says that thank you for your patience regarding the extra credit for those that volunteered to be part of the focus group. We are waiting for those in charge to provide a list of students that will receive extra credit. This is something that your Math 5 instructors, including David Hambley, have no control over. So we need to trust that it will show up before the end of the semester. If you have any questions, you can email David Hambley, but the answer to most questions will be we need to wait. Yeah. Okay. So yeah, sorry about that. Yeah, that's something that's taken care of by some other some other organization or something outside of us. So yeah. All right, very good. Okay, so we've gone over that. Okay, preparing for exam. Keep in mind there's office hours. Today is Monday, so Monday, we're already at 12:30. Maybe you went to some of the office hours that were earlier, that were there earlier today. So it looks like Tuesday will be the next day to get office hours. There's Tuesdays with David, Tuesdays with me, Tuesdays with James. There's plenty of office hours that you can take care of, or that you can attend to take care of some of your questions. All right, and that is it there in terms of announcements. Okay, so yeah, all right, good. If there are any other questions, excuse me, just put them in the chat and I'll answer them as we go. So today is basically we're just supposed to go over some review. So we can take questions on worksheet 5, right? We did quite a bit of this. I was there for the entire worksheet 5. Yeah, so I'm happy to take questions there. Worksheet 6, we did do the graphing part, together. There were videos posted on this. But I was not in class for the second portion involving the inverse trig function. So we can go over some of that stuff if you'd like. Basically just this page here, is what I was not there for. So, I'd be happy if nobody asks any questions, I'll start here. And then there's also the practice problems that we can go over. Some of these, I have not really looked through some of these, but we can also answer these. These are Alex problems, so they're more stuff that you're going to see on Alex, not necessarily that we saw in our discussion. Okay, so I'll start here with worksheet number 6, because I know I missed this part, and I'm just don't really have an idea where we all are with this. Excuse me. And I believe David had covered this class. Yeah. So let's go ahead and just jump into this. We'll take a look at the inverse cosine. And again, if you want more on this, there were a couple videos posted, and I tried to kind of explain, what each of these functions means. Okay, so the inverse cosine is, what this means is, just like it's actually very similar to the logarithm idea. When we look at a logarithm, what is the log, let's say base 5 of 25? Does anybody remember this? What's the log base 5 of 25? This was in the last, couple of worksheets ago. Yeah, and I got somebody said 2. Yes, because really we were kind of saying what exponent needs to be put on 5 to get 25. And so if we had said, okay, let's call this x, like we don't know, then we could rewrite this and say 5 to the x equals 25. And the question becomes a little clearer like this. What exponent do we need to put on 5 to get 25? And the answer is 2. So the cosine inverse kind of works the same way. The cosine inverse of 0 is equal to, I don't know, it's equal to some angle. I'm going to call it theta. Okay. And in a sense, we could kind of rewrite this equation as the cosine of theta equals 0. Notice things kind of got swapped around, right? This gets swapped here. And then the function became the cosine function, not the cosine inverse, right? So just like before, we did 5 raised to the x equals 25. And then the function, the log goes away. Notice when we rewrite it, the log goes away. The function that is now present is an exponential function, the inverse function. And so the same thing is happening here. We now have so we need to think what angle has a cosine of 0. But there's a little bit more that we need to think about. Not just what angle has a cosine of 0, but this angle theta needs to be in the range of cosine inverse, which is 0 to pi. Okay, so let's kind of break it down a little bit here. Let's draw 0 to pi. So 0 is here, pi over 2 is here, pi is there. So we're really talking about quadrants 1 and 2, like, the span through these two quadrants from 0 to pi. What angle in this, these two quadrants has a cosine of 0? And this is where we'll now go to our unit circle. And let's look up here. Cosine is the x coordinate. So in which of these points is the x coordinate equal to 0? Can somebody tell us what angle that's true for? Very good. And I see Victoria said pi over 2. Pi over 2 is correct. The cosine of pi over 2 is 0. So the answer here is 0. Really, there's not really much work that needs to be done. You just need to know, well, which quadrants am I looking at? And then which angle has the cosine of 0? In this case, it's 0. Okay, so let's try one more with cosine, because we know with cosine, we're restricted to quadrants 1 and 2 every single time, with a cosine inverse, let's say, cosine inverse. Sometimes I get a little relaxed and call it cosine, but it's technically the inverse cosine, or the cosine inverse. So let's look at another one here, and I'll give everybody, let's take 15 seconds to think about it without, answering. What angle in quadrants 1 and 2 has an x coordinate of -1/2? So we take a look over here at these points here and see if we can find that. Who's got it? Or, oh, I said 15 seconds, right? Okay, yeah, and you can send it to me as a private message. A couple of people are doing that. All right, that's 15 seconds. Very good. A couple people said 2 pi over 3, and that is correct. 2 pi over 3 has a cosine of -1/2, and therefore is the answer to this problem. Notice
Wait,
down
Professor,
here.
I have a question.
Yes.
For the one we did before, we got that the answer was pi over 2, but why did we do 0 instead of pi over 2?
Yes. Sorry, you're right. This should be pi over 2. Yes, sorry about that. Oh man, I don't know if I'm still sick or if it's just because of the I'm at home.
No worries, thank you.
Yeah, it's pi over 2. Thank you for correcting that. Yeah, that's correct. And another way to actually to do this, I like to, the way I would have done this problem without the unit circle is to think about the cosine graph that looks like this. We also should know how to graph cosine, so we can, give this. And so from 0 to pi, we're basically asking, where is the cosine equal to 0? That's what we wrote over here. Where is the cosine equal to 0 on the interval from 0 to pi? And that is right here. I'll highlight it. At that point there, the value is 0, and the angle there is, it's halfway between 0 and pi. That's pi over 2. Yeah, thank you for that. Good. So I was saying here, for this problem, our answer is 2 pi over 3. Now, I do want to just make sure to mention that, okay, that's because the cosine is negative 1/2 there. Now, if we look down here, we go straight down, we say 4 pi over 3 has a cosine of negative 1/2 as well. But 4 pi over 3 is not an answer because it is not in the interval from 0 to pi. It needs to be between 0 and pi because that's the range of the cosine inverse function. Okay, so just keep that in mind. Some people in my last class were answering that 4 pi over 3, which is incorrect. All right, good. So let's try one with sine inverse because sine inverse has a different range. And you need to know the range for sine inverse, cosine inverse, and tangent inverse. So let's practice one with sine. Excuse me. Oh, excuse me. All right, sine inverse of square root 3 over 2. This is equal to an angle theta where the sine of this angle theta is equal to the square root of 3 over 2. And I skipped a line here. With theta in the interval from negative pi over 2 to pi over 2. Okay, so we want an angle theta with theta in this interval from negative pi over 2 to positive pi over 2, where the sine of this angle is equal to square root 3 over 2. So let's figure out which quadrants are we talking about when we're talking about negative pi over 2 to positive pi over 2. Well, we know 0 is here. Positive pi over 2 is right here. Negative pi over 2 is down here. So positive pi over 2 is rotation in the counterclockwise direction. Negative pi over 2 is rotation in the counterclockwise direction. So we are talking about quadrants 1 and 4. So we need to find an angle in one of these two quadrants where the sine is square root 3 over 2. And basically, you know, since we're looking at the unit circle, sine is y over r, or just y here because r is equal to 1. So can anybody see in the first or fourth quadrant, do we have a y value of square root 3 over 2? What angle would that be? Anybody? All right, one person give me an answer here. Maybe one more, anybody else? Yes, good. Pi over 3 is correct. If we look up here, pi over 3, the sine, the y value is square root 3 over 2. We are looking for an angle whose sine is square root 3 over 2. Pi over 3 fits that. So theta, or just the answer is pi over 3. Very good. Now, some people said maybe 2 pi over 3. 2 pi over 3 could not be a solution. Even though its sine is square root 3 over 2, we are only interested in these two quadrants here. This is the range of sine inverse. If we were talking about cosine inverse, you know, then its range is these two quadrants, quadrants 2 and 3, or sorry, 1 and 2. So you got to be careful and take a look at which inverse function you're dealing with, and know its inverse or its range, and then find an angle inside of that quadrant or those two quadrants. Okay, so that's why I wanted to do a sine example as well, because the range is different. Any questions there? It takes a little bit, to get a grasp on that, I think, but we can take a look at one more of these problems. Maybe, let's see. Let's take a look at part F. The tangent inverse of the square root of 3. Okay, I'm gonna have to bring that to the front so we can see. So the tangent inverse of the square root of 3. Now the tangent inverse of the square root of 3 is an angle, let's call it theta, in the range of tangent inverse is actually very similar to the range of sine, inverse sine. It is negative pi over 2 to pi over 2, except we use parentheses rather than square brackets, because we know that tangent has some discontinuities. It has vertical asymptotes, and so the inverse tangent does not include those endpoints. So a slight difference, not too big of a deal. So this is going to indicate which quadrants we're going to be looking for our answer in. And what else is special about this angle? This angle is between negative pi over 2 to pi over 2, and the tangent of this angle theta is equal to the square root of 3. Square root of 3, yeah, we'll just leave it at square root of 3. Let's see if we can figure this out. So what quadrants are we looking at? If we're going from negative pi over 2 to positive pi over 2, that's quadrants 1 and 4. Okay, now we can actually narrow it down even more than this. For right now, quadrants 1 and 4 is where we're looking. But if you watch those videos that I posted, there was an acronym that you can use. It is all students take calculus. And what this acronym does is it tells you which trig functions are positive in which quadrants. And so this all here means that all trig functions, and here we're talking about the sine of theta, cosine of theta, and tangent of theta, all of them are greater than 0, meaning they're all positive. If the S in students represents that sine of theta is positive in this quadrant, but the other two trig functions, cosine and tangent, would actually both be negative. So in the quadrants that we're interested in, the fourth quadrant, the word calculus tells us that cosine is positive. That means that sine is negative and tangent is negative. And well, wait a minute. We're looking for an angle where the tangent is equal to a positive number. Therefore, tangent should not be negative. And so we can actually further eliminate quadrant 4 if we want to, kind of reduce down the number of angles that we need to look through. So we're looking for an angle in quadrant 1 then, whose tangent is square root of 3. So whose y value divided by x value is equal to the square root of 3. Can somebody tell us in quadrant 1, which of these angles would have a tangent of the square root of 3? Okay, I've already gotten one answer from somebody. Can we get another one? All right, good. Yes, it is pi over 3. That's what both of the students said. Pi over 3 is correct. If we look at the tangent of pi over 3, I mean, there's only two candidates. It's either pi over 3 or pi over 6, because the other ones don't even involve square root of 3. So pi over 3, if you divide the y by the x, let me go ahead and do it. We would get, square root 3 over 2 divided by, what's the other one? 1 over 2. And when you flip and multiply, this comes out to the square root of 3. So the answer here, the angle in the interval from negative pi over 2 to positive pi over 2, whose tangent is square root of 3, is pi over 3. So, you know, I write a lot of stuff here to kind of explain what's going on, but notice I'll do one more problem very, very quickly, just to kind of show, you know, how quick they can go. Okay, one more time if it doesn't work. This one here, yeah, sine inverse of -1/2. The y value needs to be -1/2, and it needs to be in either quadrant 1 or 4. It must be in quadrant 4 because in quadrant 1 sine is positive. So where is, you know, the quadrant, where is the y value -1/2? Right there. So my answer is this angle here. Now it needs to be between negative pi over 2 and positive pi over 2. If I answered 11 pi over 6, that would actually be too large. So what kind of rotation, how much of an angle do I need to rotate to get to this angle here in the negative direction? That would be negative pi over 6. That is the answer right there. Right? Notice I barely wrote anything. Now, if you use the 11 pi over 6, you should notice that that's too big, because 11 pi over 6 is, you know, rotation like this all the way around the circle to this point right here, and that's past pi over 2. And so if you wanted to use 11 pi over 6 to get your answer, you could then say, okay, 11 pi over 6, but I need to subtract 2 pi. And if I get a common denominator of 6, it would be 11 pi over 6 minus 12 pi over 6. It still gives me negative pi over 6. Okay, so you know, I wrote all that stuff for those other problems to kind of tell us the background of where the answer is coming from, but you know, it's, you know, you can write it down fairly quickly. All right, good. Any questions? Any other questions that anybody has seen that maybe you'd like to look at? If not, let's see. Could you go over the all students take calculus thing again? I didn't quite catch it the first time. Sure. Yes. Basically, it's kind of like an acronym to help you know which trig functions are positive where. You really don't need it, but it's kind of a nice little tool. So let me just quickly draw here. So all students take calculus. So let's take this quadrant, for example, quadrant number 3. Sometimes it's beneficial to know which trig functions are positive in this quadrant, in the third quadrant. Well, the word take, since it starts with a t, it tells us that tangent is a positive function here. And the other two, you know, of the first 3 trig functions that we went over would be negative. Sine theta is negative, and cosine theta is negative. Now, the reason that I say that you don't really need to know this in a sense is because, well, you know, what do you know about the x values over here? They're negative, right? The x values are negative in this direction. The y values are negative in the downward direction. So in quadrant 3, you could also just say, well, sine of theta is equal to a negative y value divided by an r value. R is always positive, therefore sine must be negative, right? You can reason this without all students take calculus. The tangent of theta is a negative y value divided by a negative x value, and you can see that the negatives would cancel, and that's why we can reason that tangent must be positive in this quadrant. All students take calculus is just a way to quickly remember which trig functions are positive in which quadrants. Okay, so does that Kind of makes sense there. And I do talk about it a little bit more in those last couple videos that I've posted. Yeah, okay, no problem. So yeah, and sometimes it's useful. It's a little useful in narrowing down, where your answer is going to come from, but you could survive without it, I guess, if you. So let's take a look at another problem then. Let's just take a look at, I think in one of the other classes I did 7B, so I'll do 7A on this one, just to give it variety in case somebody's watching all of the videos. So let's take a look at this one here. Oh wait, did we do that one? No, I don't remember which one we did. Well, whatever, we'll do 7A. So for this kind of problem, 7A, we want to find the cosine of 11 pi over 6. Okay, well, let's go and find 11 pi over 6 on the unit circle. And what is the cosine of 11 pi over 6? Can somebody tell us? What is the cosine of 11 pi over 6? Square root 3 over 2 is correct. Yeah, 11 pi over 6 is right here. Its cosine is x over r, or just the x value here, square root 3 over 2. Very good. So not really any calculation needed there. So we can replace, let me write the whole problem here, cosine inverse of, and I'll write the original problem, cosine of 11 pi over 6. So we just said that the cosine of 11 pi over 6 is equal to the square root of 3 over 2. Okay, nice. Now we're back to basically problem, 6A, cosine inverse of some value. So we want to know what angle theta in the range of cosine, which is now 0 to pi, has a cosine of that angle equal to the square root of 3 over 2. So again, 0 to pi, that's quadrants 1 and 2. We're looking in quadrant 1 and 2 to see if an angle has a cosine of square root 3 over 2. And so this is where that all students take calculus can be useful. Let me go ahead and plot this. But again, I'll show how it's not really necessary. All students, the students part tells us the sine of theta is positive. The cosine then must be negative here. Well, we are looking for an angle where the cosine is positive. Therefore, it cannot be in quadrant 2. And so it kind of just narrows down our search. Since our range is from 0 to pi, technically it could be in quadrants 1 or 2. But with the additional information that cosine is positive, it narrows it down to quadrant 1. So when we go to our unit circle, we really only have to look in quadrant 1 for an angle whose cosine is square root 3 over 2, which is right here, pi over 6. So this is equal to, our answer is pi over 6. Uh-oh. I think my pen just died. Okay, so can we see that the answer is pi over 6 right there? Square root 3 over 2. Yeah, pi over 6. So yeah, in a sense, I like to, it's more information. So I think it's nice, but you can see here, cosine is negative here. So it could not possibly be any of these answers or any of these angles in this quadrant because the cosine is negative here. That's all we're saying with that. All students take calculus. And this could be helpful in other situations as well. Trying to think of the best way to charge this thing. Give me one moment. All right. So has anybody come up with any questions? Let me unplug that here for a moment. How was the, oh, yeah, never mind. That's okay. All right. Is that okay there? Did that make sense, that problem there? It was basically just 2 steps. But very similar to the one that we did before. So let's just double check our answers here so far. We said pi over 6 for that one, right? Yeah. And this should already be posted, so I don't think I'm giving any extra information. Are we doing okay with this material? I can't see anybody, of course, so how's it going? All right. Yeah, good. So a couple of people are asking for some questions there. So yeah, let's go over. Okay, nice. All right, so let's see here. I think this thing charges pretty fast. Let me give it a try. Yeah. All right. Yeah. Give me a moment. Somebody asked for problem 9D. So we'll do 9D first, and then we'll move on to worksheet number 5 as well. All right, and 8B. Yeah, since we've had less time with that worksheet, you know, I am, yeah, we can do, I think we have time for all of them. So 9D, 8B on this worksheet, and then we can also go over number 9 on worksheet 5. All right, so let's take a look here. 9D. All right, let's take a look. So it's this problem here. All right, and just to double check, you can see my screen, right? The iPad. I want to make sure everyone's. Can you, everybody, I'm assuming you can see it. Okay, so here I just put a 1 in front of that negative square root 3, -1 square root 3. So the first step here, and I'm going to walk through these a little quicker just since we got a few, you know, a lot of questions here at the end. We would subtract 7 square roots of 3. And so we get 8 times the tangent of x is equal to -8 square root 3. If we divide by 8 on both sides, then we get the tangent of x is equal to negative square root 3. Okay. So now we are looking, the value of x is the angle whose tangent is equal to negative square root 3. So at this point, we can go back to the unit circle and check to see, remember that tangent is the y value divided by the x value, right? So we want to look at the unit circle and see if I divide a y value by an x value, will I get negative square root 3? And we had a very similar problem earlier, right? This one right here, where we said pi over 3. But now we're looking at negative square root 3. So let's go ahead and go over to the unit circle and let's find out here. Can anybody give us the angle whose tangent is equal to negative square root 3? What would that angle be? Well, we said pi over 3 earlier for a positive square root 3. So what if, and I see something in the chat, negative pi over 3? Now, okay, good. Let me go to the instructions. I should have read them out loud here. It says, find all solutions of each of the following equations in the interval from 0 to 2 pi. So in this case here, we have full, you know, there is no restriction on the unit circle. We can use the entire unit circle, and we don't have to go from negative pi over 2 to positive pi over 2. Here we're talking about just the tangent function, and we're looking at all angles from 0 to 2 pi. So let's see, I see somebody said 5 pi over 3. 5 pi over 3 is correct. The y value divided by the x value would be negative square root 3. So, let me remember this again. X is equal to 5 pi over 3. And then where's another one? There's actually another one right here. The y value divided by the x value would be negative square root 3. And that is 2 pi over 3. So these are our two solutions. Okay, because, I'll check one of these here. Let's see, let me switch back. I'll write it below here. Tangent, the tangent of, let's say 2 pi over 3. What is that? That's y over x. That's square root 3 over 2 divided by negative 1 over 2. And if you flip and multiply, you can see the 2's cancel and we get negative square root 3 over 1 or negative square root 3. Okay, so two solutions there. All right. Does that help? Oh yeah, then somebody else mentioned that. Nice, good. Very good. What was the other question here? We wanted 8b, I think somebody said. Okay, so 8b, let's take a look at that one. And I do have a similar problem to 8b in the videos that I posted. So feel free to watch that if you want some more on this. But we can look at this one. 8b. So the cosine inverse, remember what this is. When we're talking about the cosine inverse, this is an angle, let's call it theta, in the interval from 0 to pi. So in quadrant 1 or quadrant 2, where the cosine of that angle is w over 3. Now here I'm going to use the adjacent over hypotenuse language and say, if we are in, let's say in quadrant 1, let's suppose that this angle is in quadrant 1, we actually cannot restrict it any further here because we don't know if this value is, w could be a negative number and therefore be in quadrant 2, or w could be positive and be in quadrant 1. We don't really know, so let's just assume it's in quadrant 1 for right now, and let's see what happens. If cosine of theta is equal to w over 3, then that means that the adjacent side divided by the hypotenuse is w divided by 3. So we can assign the length of the adjacent to be w, the length of the hypotenuse to be 3. And then let's call this one y here, since it's in the vertical direction. We can solve for y. Remember that x squared plus y squared equals r squared. So x is, replaced by the w right now. Y is unknown. And then r is 3. That's the length of the hypotenuse. So we want to solve for y. We want to get an expression for the value of y. So we have w squared plus y squared equals 9. If we subtract w squared on both sides, then we get y squared equals 9 minus w squared. And then we can take the square root of both sides. Technically, we should put a plus or minus sign. We have y equals plus or minus the square root of 9 minus w squared. Now we can actually get rid of the negative sign, because notice that in these two quadrants, quadrant 1 and quadrant 2, y is going to be positive no matter which quadrant we're in, 1 or 2. So I'm going to delete the negative sign, and I'll delete the positive sign as well. We want the positive part. Okay, so the y value that vertical distance here can be represented by 9 minus w squared. And now we're almost done with the problem. Remember that this cosine inverse represents an angle. Well, we just drew that angle here. This is that angle theta. And we want the tangent of that angle theta. So we've drawn the angle there. We've drawn a picture of it. What is the tangent of it? Tangent is opposite over adjacent. So we want the opposite side length, which we just found to be 9 minus w squared, divided by the adjacent side length, which is w. And so this is our answer. It's in terms of w because we don't actually know what the angle is, and we don't even know the cosine of the angle. We know that the cosine of the angle is w divided by 3, but w is unknown. All right, so this is definitely a couple steps, further than some of these other problems. Okay. All right, and then the last one I saw in number 9 in worksheet 5, let me jump to that one really quick. Is there a specific part in number 9 worksheet 5 that you wanted to go over? Because there are a few of them. I think we did one of them in class last time, the El Capitan one. For the student who was asking, okay, A, yeah, let's take a look. So, Angela is standing on a tower. So here's a tower. Here's Angela at a height of 200 meters. So this is 200 meters tall. She notices a car accident at some distance from the tower. So some distance from the tower, there is a car accident. Let me just put a little car here. Okay. If the angle of depression from Angela's eyes is 35 degrees, how far away is the accident? So we want to know, so the angle of depression, if you look straight forward, that's just like the angle, just a flat, angle there. Angle of depression is how much of an angle do you have to make in order to, like, how much do you have to look down? How much do you have to rotate your head downward? And that is given to be 35 degrees. And so if we make a triangle here, or a rectangle, or whatever, it's a rectangle and we can cut it in two. This vertical distance is still 200 meters. We want to know this horizontal distance, we can call it X, and you can actually write it in two different spots and find, by finding either of these, both of those X lengths are the same. And so then we can ask ourselves, okay, with this angle of 35 degrees, I have two values. With respect to the 35-degree angle, they are the opposite and adjacent sides. So it might be good to use either tangent or cotangent. Let me see here. Let me set up the angle for tangent. The tangent of 35 degrees is equal to opposite over adjacent. We did say in class that it actually would be better if we can have the variable on top. So for that reason, I'm going to use cotangent instead, the reciprocal function. You could do it with the tangent, and that can be solved, but it's going to take an extra step and some division of decimals. It might be easier just to look at the reciprocal function, cotangent. It's equal to then adjacent over opposite, x over 200. And if we just do one step here, multiply by 200 on both sides, then we have x by itself. X is equal to 200 times the cotangent of 35. Cotangent is here, 35 degrees is here, and so the cotangent of 35 is 1.43. And when we multiply by 200, we get 286. And I think my pen just died again. So 286 is our answer. Okay, does that make sense there? I'm not sure if that. We would get a very similar answer if we solved the tangent equation. Maybe slightly different, maybe, but around 286. And I believe if we take a look at the solution, that's what the answer is. 286 meters from the base of the tower. Yeah. All right. So it is 1:20 now. So, we can officially stop here. If you have any questions, feel free to stick around. The exam is on Wednesday. So we will do that in-class portion in class. And then there's also an online portion, which you're welcome to have completed before you get to class. For the ALEKS exam portion, you can do that before you get to class if you want. that would be nice. But the in-class portion is still going to happen in class. This is the only time we're meeting online today. Wednesday will be. Oh, thank you. Yeah, hopefully I do feel better. I do feel a little bit sick still, but I'm okay. Thank you. Though. All right, I will see you all next time. Look out for the announcement. I'm going to send out the videos in just a few minutes. You can watch any of the classes that I've done today. All right, so I hope you all have a good day, and I'll see you on Wednesday. Stick around if you have questions. I'll stick around for a few minutes until everybody's gone. All right. All right, we've still got a couple people here. Jesus, Christian, Jer, Maria. Do you all have any questions for me? Oh, thank you. All right, you too. Thank you. I appreciate that.